In class today, we finished up our discussion with the horizontal translations by graphing 1/2 sine of quantity x plus pi, and we talked about how this was just a phase shift or a horizontal displacement to the left by pi radians. And so when we graphed that, we found that it was similar to the original graph of sine x. We just had to make a few changes. So our center line is still the line y equals 0. Our ceiling is 1/2, since we have an amplitude of 1/2 here. And our basement, as Kelly calls it, is at negative 1/2. Now usually we start sine at 0. But because we have a phase shift to the left by pi, we're actually going to start at pi and use that same motion that sine makes. Sine begins in the middle, and then in every phase it goes up. So I'll be up here, and then I'll be back to the middle, down, back to the middle, up, back to the middle. And so starting from pi, I should expect to see a curve that looks like this. And if you care to continue it on the other side, then you can see how that wave will be created as well. Now with our next graph, we have y equals 3/2 times cosine quantity x plus pi over 2. We have an amplitude change of 3/2, and we have a phase shift of negative pi over 2. So we will need to keep these in mind as we are creating the graph of cosine. Now I've already set up the intervals here for the way that we usually see them, which is 1, 2, and 3 here. However, we now need to look at the amplitude, which I will be at 3/2, and for the maximum, and 3/2 for the minimum. Because there's no displacement, my center line or sinusoidal axis is still the line y equals 0. However, I do have a phase shift of negative pi over 2. And so because of that, instead of beginning cosine at 1 for the 0 radians, I would have to move back to negative pi over 2 radians and then begin at 1 and continue with cosine's behavior. So at negative pi over 2, I'll be at 1. And then cosine then goes to the middle. Sorry, let's go back with that. That should be 3/2, 1/2, at negative pi over 2. And then cosine goes to the middle, and then down to the basement. Sorry about that. Let's try this one more time. We are starting at the ceiling at negative pi over 2. Middle at 0. Basement at pi over 2. Middle at pi. Ceiling at 3 pi halves, and then middle at 2 pi. So I get a cosine curve that kind of does this. And if I continue that back on the other side, then I can see two full, well, maybe not full periods, but 2 full periods of cosine, just about 2 periods. And get rid of that. Okay. So on the next slide, we look at our last topic, and that is horizontal stretches and compressions. So you can turn your page over now to the last page. So here we can see the horizontal stretches will affect the period. And this is because it affects how many repetitions or cycles the sine or cosine curve will make in a given interval of x values. So take a few moments and graph y equals sine x on your calculator in y1, and then graph the others, y equals sine 5x and y2, and the other subsequent equations, in order to compare what happens with y equals sine x and y equals sine 5x, sine negative 3x, sine 1/3 x, and sine negative 1/2 x. Pause the recording while you do this. There's a zoom trig feature on your calculator to help scale your graph so that you can see how these work out. And on the 8384s, that's zoom followed by 7. Hopefully you noticed that when the b, the coefficient in front of x, is a whole number, that we get more cycles of sine. That's because this is a horizontal compression by a factor of 1 over b, which means that I have a shorter amount of time to complete a cycle. So I'll complete more cycles over a given time period versus just the regular sine x. And when b is less than 1, or a fraction, that this becomes a horizontal stretch, and I have more time to complete a cycle, so I'll have fewer repetitions versus the original sine graph. So if we kind of compare what happens if I'm given the function y equals sine bx, that the period has the formula of 2 pi over b. And that's important because you need to establish your period as you're setting up your intervals. So let's take a look at what happens, and we'll graph one period of each of these by hand. For y equals 3/2 sine 2x, my period is 2 pi over b. In this case, that will be 2 pi over 2, which is pi. So I'm going to complete one cycle in pi radians, whereas I used to complete a cycle in 2 pi radians. Notice that I have no vertical displacement, not adding or subtracting anything at the end here, but I do have an amplitude change of 3/2. So my center line, sinusoidal axis, is at 0. And so within the intervals, I am doing something different each time. So I will begin at 0, as I always do, and I will, because it's sine, I'll start at 0. And then in between this interval, halfway in between, I have to go up to the ceiling. And then I'll come down, and then down to the floor, and back to the middle. And that is one complete cycle of sine. But notice what's happening here, that if I actually go a distance of 2 pi so that I complete it on the other side, I'm actually getting more repetitions within this period than I would with a period of 2 pi. So over a distance of 2 pi, I'm getting 2 repetitions of sine because the period has now been changed to pi. Now for our next example, in order to make it more reasonable here, we're going to have to make some changes to the grid. Let's start with the period though. The period is going to be 2 pi over b. In this case, b is 1/4. And so I have a distance of 8 pi in order to complete one cycle of cosine, which is going to stretch cosine out so that it's 4 times as wide horizontally as it was before. My ceiling is 1/2. My floor is -1/2 since there's no horizontal displacement, and my sinusoidal axis is still y equals 0 here. But what I want to change is I want to change this endpoint so that it's 8 pi, and on the left I want to make that -8 pi, which means in the middle here this will be -4 pi, and then on the other side in the middle that will be +4 pi. So that way I can set up my intervals in a similar fashion by splitting my period up into 4 distinct phases. Cosine usually starts at 1, which was the amplitude, but now we're going to start at 1/2. There's no phase shift, so we're just going to go to 1/2. And then at the center line I come down to 0. Notice that this is 2 pi. And then at 4 pi, I'm entering my phase here. I am on -1/2. Get rid of this dot here. And then I go from there back up to the middle and then back up to 1/2. And so that completes one cycle of cosine from 0 to 8 pi. In order to see the true effect of this, you would have to graph it on the same grid as pi so that you could see it really is stretched out a little bit more. Let me finish this left side and I will do just that for you. So that's the cosine graph that we have as you see it. Let's take a look at what the regular cosine curve would be. I just noticed that this is completely incorrect. Let me fix this for you. That dot is supposed to be at 1/2, not -1. So your cosine graph looks like this. Hopefully that's better for you. So the regular cosine graph would do something like this. Because it usually starts at 0, 1 and finishes at 2 pi 1, the cosine curve has that distance to finish all of its intervals. Halfway in between here is pi, and that pi cosine ends up at -1. So what we find is the cosine curve doing something like this in one cycle. And then I have to repeat that same thing to go through 4 pi, and that same thing to get to 6 pi, and then back down. So you can see that that curve has been stretched out according to the scale that we have here. Now what I'd like for you to do is to go back to the blog, and these questions down here at the bottom that say find the center line, minimum, and maximum, you're keying these answers into the blog. This is required. I do expect you to do this, and I will be looking for your answers tonight, and possibly even email you with some guidance or put some information on the blog to make sure your understanding is correct. You do have to put in your first name and last name so I will know who has and who has not done this. So please follow through on your assignments. We have no class tomorrow, and I am out on Thursday and Friday, so certainly if you have questions, please ask.